Students, yesterday we have seen the expression for electric potential due to dipole on axial as well as equatorial point. Today we'll see the electric potential due to system of charges. Means already we have seen electric potential due to single point charge, and the expression is if only one charge is there and due to that charge the electric potential is given by, it is nothing but electric potential due to single charge is equal to 1 upon 4 pi epsilon naught, that particular charge divided by distance of that charge from point P. So here two things we have to remember. Electric potential is inversely proportional to the distance if charge is constant, and this 1 upon 4 pi epsilon naught 0 is also constant. So basically electric potential is totally depends on the distance of that charge from that particular point. So this is all about the single point charge. Now we have to solve the problem if what will happen if you make the number of charges in the system. Okay, so this is for one point charge. Now we'll see next point, electric potential due to the system of charges. Now just imagine that a system or any XY plane having n number of charges like Q1, Q2, Q3 up to Qn, and distance R1, R2, R3, Rn respectively from any point P. Now what is our problem? What we are supposed to find? Here we are supposed to find the electric potential due to this Q1 charge on point P. Similarly, electric potential due to this Q2 charge on point P up to electric potential due to Qn charge on point P. So combinedly we can say that we are supposed to find what is the electric potential due to all these charges on point P. So we'll start. So just imagine that or consider number of charges, okay, in system at distance R1, R2, R3, R1, Rn from point P. But we know that the definition of electric potential due to single point charge or expression V is equal to 1 upon 4 pi epsilon naught charge upon distance from that point P, isn't it? Now we have to apply this formula for charge Q1. So if you apply, we can say V1, listen it very carefully my dear student, V1 is electric potential due to Q1 at point P. V2 is electric potential due to charge Q2 at point P. Similarly, V3 is electric potential due to charge Q3 at point P, and up to Q1, that is Vn is electric potential due to this Qn charge on point P. Okay, so similarly we can find electric potential from this formula due to Q1 is equal to 1 upon 4 pi epsilon naught, as it is charge Q1 upon distance R1. Got it? Similarly, V2 is equal to 1 upon 4 pi epsilon naught charge Q2 upon R2. So for charge 3 we can write V3 is equal to 1 upon 4 pi epsilon naught Q3 upon R3. Similarly, Vn is equal to 1 upon 4 pi epsilon naught Qn upon Rn. But as I said, electric potential is the scalar quantity. So we can add the electric potential produced by all individual charges by using algebraic sum formula, or we can do this addition simply. So the total electric potential V is the algebraic sum of the all individual electric potential produced by all charges or all individual charges. So from equation V1, V2, V3 up to V1, Vn, we can write total V, that is electric, this V is final or total electric potential due to system of charges or all charges combinedly is equal to 1 upon 4 by epsilon naught is common, so we have taken it outside. In bracket, this Q1 upon R1 plus Q2 upon R2 plus and so on up to, here we have tried plus and so on up to plus Qn upon Rn. So here my dear students, we can take 1 upon 4 by epsilon naught common, and summation of, we have to do summation of this all, summation of I stand for 1, or I is equal to 1 to En, that is Q1 to Qn. Qi upon Ri. So this is the expression for electric potential due to system of charges. That is V is equal to 1 upon 4 pi epsilon naught summation of I is equal to 1 to n, that is from 1 to n Qi upon Ri. So hope you understood, my dear student. Next point we'll see now, equipotential surfaces. Okay, so as we know the electric potential formula, V is equal to we know the electric potential formula, V is equal to 1 upon 4 pi epsilon naught, that is K is the constant, Q upon R. Means here it is very clear that electric potential is inversely proportional to distance. Clear? Inversely proportional to distance. So here if you calculate or if you describe electric potential due to single isolated positive point charge, so as we know electric field is going away or radially outward from single isolated point charge. Okay, so if you draw the concentric circles with increasing radii, then we can say the electric potential for particular circle, for example if you consider this circle only, okay, the electric potential is same because for this particular circle the R is constant, that's why electric potential is also constant. So for equipotential surface, in order to calculate or equipotential surface for single isolated positive point charge, we can show by using this figure. Okay, then due to two equal and opposite charges, as we know during the electric field line property we have done this part also. Electric field of lines started from positive and it ends with negative, so that we can show this figure, that is most of the lines are emitting from positive charge and their ends with negative charge. Okay, as they are attracting each other, as they are unlike charges. Similarly we can find the electric potential due to positive charge or due to negative charge, they will repel. So here only arrow you have to show, arrow, because if you are showing positive charge, single positive charge, both are like charges, then you have to show the arrow electric field of lines going away. Okay, and if you are showing negative charge, then we have to draw electric field of lines are coming towards that negative charge. Getting? So already we have done this in electric field. Now this is very important point, 4th point, electric potential due to uniform electric field. Now just imagine that this is a uniform electric field. Okay, E is uniform electric field. So the electric potential due to uniform electric field is represented by the parallel planes, so that the electric potential in this plane is always constant because it depends on the R. So if R is constant, distance from that point is particular point is constant, then electric potential is also constant. So my dear students, in examination many a times they may ask for, if you see the previous question paper, definitely you will find any of this figure, means they may ask draw the equipotential surface or show the equipotential surface for single isolated positive point charge or due to equal and opposite charges or equal positive charges or equal negative charges or due to uniform electric field. So these all points are important for 1 to 2 marks, it may come in the examination. Now today's our next point, electron volt. So simple definition, this is last point, today's last point, electron volt. What is electron volt? Actually electron volt, it is the amount of energy gained by electron when displaced from one point to another point. As we know electric potential, the definition of electric potential is nothing but it is the amount of work done required to bring the unit positive charge from one point to another point. So here simple concept we can apply, it is the amount of and what is electron volt? Simple concept, it is the amount of energy gained by the electron when displaced from one point to another point. Means suppose initial electron is at place A, okay, and if it is moving from A to B, so this electron will gain some energy and that energy can be calculated by simple term, that term is called as electron volt. So once again my dear student, this is very easy definition, electron volt is nothing but it is the amount of energy gained by an electron when it displaces from one point to another point. So we'll see the proof of this, means mathematical formula and its numerical value. We know that work done is nothing but potential into charge, electric potential into charge. So SI unit of electron, SI unit of energy, we know that it joule or electron volt also. So we can write 1 electron volt is equal to work done. But work done is nothing but potential difference into charge. So potential difference, that is 1 volt, charge unit coulomb, so 1 coulomb. So we can write electron volt is equal to work done is equal to 1 coulomb into 1 volt, because charge ka unit coulomb, potential difference volt. So we can write 1 coulomb into 1 volt. But we know that 1 coulomb is nothing but 1.6 into 10 raised to minus 19 joule into 1 volt, isn't it? Now if you concentrate this step on this step, so 1 electron volt will be 1.6 into 10 raised to minus 19 joule, because this is energy and it is calculated in joule only. So my dear student, do remember this formula. 1 electron joule is always equivalent to 1.6 into 10 raised to minus 19 joule. Again, if you see here, 1 kilo electron volt. Now 1 electron volt is nothing but 10 raised to, are you getting my point? Means 1 kilo is nothing but 10 raised to 3. Okay, so here 1 kilo is nothing but electron volt, that is 1.6 into 10 raised to minus 19. As kilo we are applying, so we have to multiply by 10 raised to plus 3. So it will come 10 raised to plus 3, 10 raised to minus 19 will, so 3 terms will get cancelled. So it will come, the final expression for 1 kilo electron volt is equal to 1.6 into 10 raised to minus 16 joule. Similarly, 1 mega electron volt is equal to 1.6 into 10 raised to minus 13 joule. Okay, so this is all about the mathematical steps. So once again, my dear student, electron volt is nothing but it is the amount of energy gained by an electron when it is displaced from one point to another point. So what is 1 volt? 1 volt, when 1 joule amount of work done or energy is required to bring 1 coulomb charge from infinity against the electric field. This is a very simple definition, my dear student. If you know the definition of electric potential, then 1 volt is very easy for you. Once again, see, it is 1 joule amount of work done or energy is required for what? To bring 1 coulomb charges from infinity against the electric field. So this is all about the today. Hope you understood today's lecture. Today we have seen 3 points. First, electric potential due to system of charges. This expression we got it. Second, very important point, many times this question have come, or these questions have come in the board examination, CBSE board. This electric potential due to single charge, pair of charge, single isolated or two equal or opposite charges, and at last due to uniform electric field. And last definition we have seen electron volt and 1 volt. Thank you.